Are we live? Oh, we are. Welcome to another Tech Day hosted by me, the Duke. I wanted to segment today's episode, and I hope it will be a longer one because I hope to do a lot of things. First thing I wanted to do is where are you? Where are you, Paul? You are here. It's Hacker News. And what I wanted specifically to do is, yeah, maybe I'll take a look at some of these things. But oops. The thing I wanted specifically to do is can I all right, let's do it like this. So yeah, I want to see who is hiring and then I want to see what kind of requirements are needed for these positions that are being offered. Again, I've been working in my current company for 4 years and I haven't been on an interview since that period. So for me, it's something new. It's interesting. I need to see how the industry works, how it breathes now, especially after this AI revolution. Relays is hiring for code LLMs. Here we are. Technical team building code generation models and growing fast. We're looking for people who are down to scrap and love to build on both a technical and GTM developer. No. RT is hiring engineers, AEs, and senior PMMs. All right, I'm interested in the engineer's position. We are a small team based in San Francisco looking to hire a founding engineer that has dedicated focus around distributed systems. Okay. Okay. To wear multiple hats, directly interact with our customers and play a crucial role in shaping the future of our product. So most of these are just buzzwords. The important thing is the position itself, and it's the position of distributed systems. This is a challenging and dynamic role, and you will be working at the forefront of data engineering, distributed systems, and infrastructure. Building column encryption, launching our analytics portal, and schema change alerts. Building tooling to streamline and automate infrastructure workloads. Introducing pipeline efficiency, blah, 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 blah. Okay. Okay, what are we looking for? Strong fundamentals in computer science. Pragmatic and care more about building the right thing versus being right. Comfortable jumping around the stack and wearing different hats. This is almost necessary in today's ecosystem, in today's environment. Someone that wants to take an active role in defining the next gen data platform that utilizes stream processing and CDC to drive data latencies to zero while also focusing on ease of use and extensibility. All right. Past experience working on scaling async systems and exposure to topics like GPRC, Kafka, Kubernetes, Helm is preferred but not required. This is good because I've worked with both Kafka and Kubernetes before. Proficiency writing in Go is preferred but not necessary. Happy to work in person 5 days a week in San Francisco's financial district with the rest of the team. TypeScript, backend, Terraform, Kubernetes. All right. So there is an interview, 1 hour technical phone screen. What are we looking for? So a lot of interesting things here. So what am I specifically interested here? Oop. Is this working? Please configure both. Okay, this is a warning. My stream is broken, but hopefully it's not, but it seems like it is. Okay. Like the front end seems easy if it's only in TypeScript. Go, Postgres, Redis, Kafka, and Elasticsearch. Terraform, Kubernetes, and Helm. All right. We are building RT, a real-time data streaming solution focused on databases and data warehouses. So first of all, let's decode some of the keywords. Distributed systems. So basically, a distributed system is consists of independent computers, and they work together as a single system to provide, I don't know, high availability, scalability, low fault tolerance, stuff like that. But in order for this to work, the machines need to coordinate. They need to be consistent. They need to be responsive, even if some fail. For example, in Kafka is yeah, maybe we can do some Kafka work after this. Well, let's wait. So it's a distributed messaging system, and then you have Postgres with like application which is a distributed database. AWS, even though I never worked with it. S3 is a distributed storage system. Blah 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 blah. What are some other buzzwords? Column encryption. So what's this? Just encrypting sensitive database fields at the column level. All right. Was schema change alerts? So most probably their database is quite fiddle. It will change a lot. Like, I don't know, adding, removing columns, changing types, stuff like that. What else? What other buzzwords or keywords? Tooling to streamline and automate infrastructure workloads, like Kubernetes and Helm. Maybe I'll do some of this right now. So there's a lot of work. There's like a lot of architecture work, most probably. A lot of DevOps work, like Kafka and Postgres and Kubernetes and Go, most probably. What else? I mean, a positive thing that there's like only a 50-minute call with the CTO, a technical phone screen, and then an on-site interview, and that's it. Like, you don't need to pass 20 different hoops in order to be employed. Hopefully it's only these 3 steps, these 3 levels. So yeah, seems interesting. I don't know, 15 minutes call with the CTO. most probably you will be asked what kind of problems you solved in relation to all of this, in relation to to architecting and building distributed systems. Oops, I have a call. I'm really sorry. What else do we have? The technical phone screen. Most probably, we will need to build a producer-consumer pattern in I don't know what do we have? Go, most probably Go, and stuff like that. Maybe I'll do something like this now. And there are a lot of other things. I don't know a lot about this. Not gonna lie. I know the basic. I know the theoretical part, but about us, what are we looking for? What's this here? Founding product engineer. All right, so this is not technical, is it? Just a second. I'm having a call. I will come back. Apologies. How do I mute you, brother? How do I mute you? Do you hear me? Okay, I'm back. So, not exactly my cup of tea, but I think Kafka is really interesting to go deeper into it. So let's maybe do Kafka. Maybe there's a YouTube video for Kafka. So what's this? Reject, I don't need it. Wait. Intro to Apache Kafka tutorials, explainer videos, and more. All right, so what's Kafka? This beginner's guide features Apache Kafka courses and tutorials that will help you learn key Kafka concepts and how to get started from the ground up. It includes a look at Kafka architecture core concepts. So, concepts. So let's start with Kafka. I worked with Kafka a lot in my day-to-day, but mostly, just a second. Is this working? Yeah. Try this Apache Kafka hands-on tutorial. So are these step-by-step tutorials? Hands-on tutorials, Kafka Streams. Okay. So what's Kafka? To start, Kafka is a data streaming engine used to collect, process, store, and integrate data at scale. It has numerous use cases, including distributed event streaming, stream processing, data integration, publish, subscribe, messaging. Before delving into Kafka architecture or its core concepts, let's discuss what an event is. This will help explain how Kafka stores events, how to get events in and out of the system, and how to analyze event streams. So what's the first thing? Kafka is a data streaming engine used to collect, process, store, and integrate data at scale. So a data streaming engine means it's a hub, it's a brain where data just keeps, like, the neurons are just firing. The data never stops arriving. The data never stops going. Kafka is that hub that handles the constant flow of information in real time. Kafka is the brain. Collect. So Kafka takes data from many sources, like, I don't know, like what, web apps, databases. It could take sensors, logs, and then it says process. Basically, we can filter, transform, or enrich data while it's moving. Like, if we imagine that we are firing neurons, there is data being sent, between neurons, going to and from our brain, we can, stop it, change it a bit, bam, send it again. So Kafka is like a brain sending and receiving data. We can store it, if I'm not mistaken, and I shouldn't be, because I worked with Kafka a lot, at least on a simple scale. Kafka is keeping
When I first got into development, I remember being confused about two things. One, I didn't know what the point of Docker was, and two, I thought that Git and GitHub were the same thing, but that's not the topic of today's video. The topic of today's video is things I actually use Docker for. And if that makes it sound like I'm being paid to say that, it is because I am being paid to say that. That's right, Docker is sponsoring this whole video, so there's no skippable section. Unless you skip the whole video, but don't do that. Being honest, I do use Docker quite often. I even had a whole section planned for my last video, but I removed it due to time constraints, so I really wanted to take the sponsorship. I don't want to make this video tutorial though. There are many good Docker tutorials available already. So instead, I want to show some practical ways I use Docker in my day-to-day life. I will explain some terms and commands, but I'll keep it as simple as possible. So if I don't explain a command too in detail, that's why. Before starting, there are three things you need to know about Docker. Docker images, Docker files, and Docker containers. A Docker image is a template that contains all the necessary configurations and files to create a container. Docker images can be created via Docker files, which define how your image will be configured. They can also be pulled from a registry if somebody else made them before. Finally, Docker containers are the simulated machines that will run a Docker image. Containers are not VMs, but for simplicity, you can think of them like small computers that will run your Docker images. And that's all you need to know for this video. So without further ado, let's proceed to some Docker use cases. One of the main things I do with Docker, or rather one of the things I avoid doing thanks to Docker, is having to install things in my computer. And what do I mean by that? Well, let's pretend for a second that you're a sad developer who has to code on Windows, and you need to install some database like MongoDB. Now I don't know why, but every single time I've tried installing MongoDB on Windows, I always run into the weirdest issues. I swear, every single time I get a new one. I don't even know how that's possible. Let's also take into consideration that once you're done with MongoDB, you have to uninstall all the individual components one by one, which at least to me, it's very annoying. Thankfully, there are two good solutions. Number one, don't use Windows. Number two, use Docker to install MongoDB. This is actually one of the installation ways MongoDB suggests in its documentation. First, you need to pull the official MongoDB Docker image by running docker pull. Then if you do docker run, you will create a container using the image you just pulled. This container will behave just as if a database was installed on a separate machine, except that the machine is just a Docker container, like in The Matrix or something. I don't know, I never watched the movie. Finally, once you're done with MongoDB, you can stop or remove the container, and there you go, no more bloat. Besides being pretty straightforward, installing a database using Docker allows you to follow the same steps regardless of your operating system. For my last project Mogul, I installed both Redis and MongoDB this way. Be careful though, because if you destroy a container, all the data stored within the container will disappear, which is not very good when you work with databases. But of course, there are ways to store the data outside the containers and mount the directories you need. It's not an obscure thing to do at all, and it's actually very common. But I still have to run two commands to install this. Isn't that annoying? Yes, container, and there you go, no more bloat. Besides being pretty straightforward, installing a database using Docker allows you to follow the same steps regardless of your operating system. For my last project Mogul, I installed both Redis and MongoDB this way. Be careful though, because if you destroy a container, all the data stored within the container will disappear, which is not very good when you work with databases. But of course, there are ways to store the data outside the containers and mount the directories you need. It's not an obscure thing to do at all, and it's actually very common. But I still have to run two commands to install this. Isn't that annoying? Yes, but have you tried installing shit on Windows? Anyways, after running a bunch of commands, you'll need to manage all the images and containers you created. You can do this in two ways. One, you can use the terminal. Two, you can use Docker Desktop. I love CLIs as much as the next Linux guy, but sometimes I do use Docker Desktop. It just simplifies things a bit when you have multiple containers you need to manage, and in case you need to examine them more in detail, which I had to do to debug the query engine in my Mogul video. It's also integrated with Docker Scout and Docker Hub, so it kind of just streamlines the whole process. And just to prove I'm not making shit up, this is an actual conversation I had with a friend months ago. And just to wrap up this section, some Docker commands that are useful to know are Docker PS to list active containers, Docker PS-A to list all containers, keyword being all, Docker image ls to list all images you've pulled, Docker run to run a Docker container, and Docker system prune --all --volumes, which you'll need once you start creating containers and get gigabytes and gigabytes of data. Another thing I like doing with Docker is to avoid installing dependencies. This is similar to the previous point, but instead of talking about third-party software products, I'm referring to dependencies in my own projects. This happens a lot when you work on projects that require you to install packages and packages of things you'll never use again. Think for instance a Python project that requires pandas, matplotlib, nltk, mainfuckfuck, miniglib, and many other libraries. And while you could use a virtual environment, and that's what some people do, personally I always forget to either create a virtual environment or to activate it, and by the time I realize it's already too late because I cluttered my global Python environment with useless packages. To avoid this, we can use a Docker file. This is the configuration file that you usually put in the root of your project in an environment with useless packages. To avoid this, we can use a Docker file. This is the configuration file that you usually put in the root of your project, and it tells the Docker engine how to create a Docker image based on your needs. So for example, I can write a Docker file that looks like this. It starts from a lightweight Python image. Most Docker files will use a base Linux image with some tools already installed, so you don't have to waste time installing them yourself. This ensures a fresh installation each time, sort of like setting up the operating system of your VM, even though, again, a container is not a VM. Then it installs the project's specific dependencies and sets up the necessary things for the image. Finally, it specifies some commands to run when the container starts from a Docker image. Image. To build this image, all you have to do is run this command, and then this command to run a container with our newly created Docker image. And just like that, our application is running without having to install any dependencies in our machine. And that's also something cool about Docker. Besides allowing you to avoid installing dependencies, it also allows you to replicate all the things you would normally do, but in a clean environment. Docker Compose is a utility that allows you to define and run multi-container applications, which means that if you have a big project that requires you to run 10 different projects at the same time, instead of having 10 different terminals opened and installing more dependencies, you can just use Docker Compose to set up everything with one command. Last semester, I had to work on my bachelor's thesis, and one of the things my teammates and I had to do during the research process was to develop a simple web application in Next.js, which sounds simple enough. However, I had the great idea of using Redis as a database. And while Redis is a great tool and I fucking love Redis, my teammates, reasonably enough, didn't want to install another tool in their computers. Shout out to my teammates though, I couldn't have finished the thesis without them. This is where Docker Compose came in handy. This thing here is a Docker Compose file, and it is just a YAML file. You can use it in conjunction with your Docker files and Docker images. In this case, I have defined two services, Vidra, the name of our application, and Redis, the database we were using. Vidra is defined locally via a Docker file, while Redis is pulled from a pre-made image from the official registry online. If we run this command here, Docker will build and or pull these images and run all the containers at the same time. In this case, I had only two, but you can define a bigger number if your project needs it. And another cool thing that you can do with Docker Compose is to define the number of replicas you want to have for a specific service. In my search engine video, I mentioned that in order to collect the data of websites, I coded something called a spider, or a web crawler. And while one spider is decently fast, 40 spiders are certainly faster. So by using Docker Compose, I managed to run a shit ton of spiders at the same time. You could also dynamically scale up or down the number of replicas by executing this command. A related use case of Docker Compose is the implementation of load balancers. And while Docker is not a load balancer, you can use Docker Compose to help you set up a load balancer using tools such as Nginx, tchdy, or Traffic, which are just reverse proxy or server programs. I talked a bit about load balancers in my previous video. Granted, I don't have to set up load balancers every day, but I've done it at least twice in my life, which is more than enough. CI/CD, or continuous integration and continuous deployment, is, in simple terms, automating your development process via automatically performing sanity checks on your code and or automatically releasing new versions of your software each time you need it. This is something I covered much more in depth in the original script, but explaining it messed up greatly with the flow of the video, so to summarize it, when you develop software, there's usually a series of steps that you have to execute all the time to run tests, compile, and deploy your final product to the users. You can think of a CI/CD pipeline as a way of automating these steps, and by using Docker you can facilitate the whole process. For example, in a build job you could just build a Docker image, and in a deployment job you would just push that Docker image to a registry or just upload it to a server. Some services like Google Cloud Run even allow you to directly push Docker images so you can host your applications there. CI/CD is enough for a whole video, and I really want to keep it as simple as possible, but you can check my Mogul repo if you want to see how I use Docker in that CI/CD pipeline. I'm gonna be honest, this last use case is not something I do often, but it is something you can do and I think it's fun to showcase. Of course, one of the easiest things to do with Docker is to set up servers for some of your online games. For example, you can set up a Minecraft server easily with Docker, and there's actually a very popular repo with a bunch of configuration options. But a server does not require you to run any graphics, so can you run a game with graphics through Docker? The short answer is yes. Why would you do this? Well, to be honest, it's mostly for fun. Let's say you want to play Doom, but you don't want to play the port. You want to play the OG one released for MS-DOS. Sadly, if you try running that, you will most likely not be able to run it, unless you're running FreeDOS, but why would you do that, I guess? You could use an emulator to play the original game, but if you use Docker, you can set up the configuration once, push it to a repository, or store it somewhere in your computer, and each time you want to play Doom, you can just run one Docker command. So in this basic project, I just set up a simple Ubuntu image that uses DOSBox, an MS-DOS emulator, to automatically run Doom when the image starts in a container. Now that's the easy part. The tricky part is getting graphics to show up. Docker containers can't access your screen by default, so we have to use something called X11 forwarding, essentially telling Docker to redirect the graphics to our actual monitor. In order to fix that, at least on Windows, you have to install an X11 server. So don't worry about the details, this is a huge rabbit hole and this video would be too long otherwise. The point is that if you configure it properly, you can run the original Doom in a Docker container. You could also configure it to install an MS-DOS operating system instead of using an emulator, but that's too much hassle. Now there are only two more issues to fix. One, there is no audio. This one's fixable, I just don't want to do it right now. Two, and most important, I don't know how to play Doom. And that was the video. Just some quick updates about the channel and some of my projects. If you watched my last video, you may have noticed that Mogul, my search engine, is down. I was not planning on keeping it running forever, so you won't be able to use it anymore. Now I did look at the pull requests I got, but I've had little time lately because I have a job now, at least for the summer. So if you submitted a PR, I will eventually accept some of them. That being said, I will make a few videos during the summer, but they will most likely be chill videos where I talk about things. I will return to project writing during the fall. Thanks again for watching.
Is my mic work? You must be joking. My mic wasn't working. Oh no. Oh no. Since when? I need to stop this. Sorry. I need to stop this. I'm gonna continue. No wonder no one joined. My mic wasn't working. Fuck.